Hi students, look where we are. We are standing in a very beautiful landscape of Kanyakumari district. This is Thiruvattara river. So now you know the topic what we are going to discuss today. We are going to discuss on water. Water is an essential component of our daily life. Maybe life can exist even without love, but not without water. So we use it for our day-to-day existence, washing, cleaning, cooking, right? It is part of us, drinking. Now, there are two main sources of water. One is surface water. So this is one example, river, lakes. And second one is groundwater, wells, okay, tube wells, bow wells, all those things will come under groundwater. Okay, so we'll be studying on that. Then we'll also be discussing about hardness of water. So what is hardness? When we have calcium and magnesium salts in water, we call that water as hard water. Okay, there are two classification of hardness. One is temporary hardness and the other one is permanent hardness. So what is temporary hardness? When we have bicarbonates, when calcium and magnesium is present in the form of bicarbonates, we call it as temporary hardness. It could be removed easily. Just by boiling it, we can remove it. So we call that as temporary hardness. And the second hardness is permanent hardness. So when we have calcium and magnesium salts in the form of chlorides and sulfates, okay, we call that as permanent hardness. Now we need some methods, special methods to remove the permanent hardness. We'll be discussing on that also. Okay, and in the lab, if you remember, we have carried out estimation of hardness by complex or metric titration method. So we'll be studying on that also, how to estimate hardness, that is permanent hardness, temporary hardness, total hardness. So we'll be discussing on that. So this hardness, it is creating a lot of damage in our household and also in industries like clogging, okay, discoloration. So a lot of problems is faced, especially in industrial sector. So we'll be discussing on that also. So we have a lot to study. So shall we cherish chemistry with water? Just admire it, how beautiful it is. Hi students, we have a very important topic to discuss today. So that is on water. Water, there are various sources of water. We will be discussing on that. And how is water classified based on its hardness as temporary and permanent hardness? And then the units of hardness, and also how to determine this hardness in a laboratory. So we'll be discussing on the complex or metric titration too. So we have a lot to study. Water, no, it is a very vital natural resource, and that forms the basis of all life. No, it's a very marvelous gift to us from nature. No, 70% of the earth is made up of water, and even the human body is made up of water, and all plants and animals, they also contain water. Water, it regulates the earth's temperature, and also it regulates the temperature of the human body. We all know that pure water does not have any smell or any taste, and its pH level is neutral, that is around 7. But what we drink is a mineralized form of water. So what we obtain from the river or surface is mineralized form of water. So you have salts in it, and that's why you have that taste too. Water, no, though the quantity of water available on the earth is huge, but its distribution is not uniform. Now, if you see, 97% of the water is salt water. Now, it is found in seas and ocean, but only 3% is fresh water, and even in that, two-thirds of them it is found in frozen form, that is in glaciers and in polar ice caps. So the remaining unfrozen water. So just remember how careful you have to be in using the trace quantity that God has given us, with utmost care. So that is only found above the ground level, which we call it as surface water. So, and that surface water or the fresh water, it's a renewable resource. We all know that we get it from through precipitation. And here we see a diagram which represents the distribution of water on Earth. If you see 97% is saline and fresh water is 3%, and in this 3% that is distributed in ice caps and glaciers. How much? 68%, and 30% in the form of groundwater, and the remaining as surface water, and that is again distributed in the lakes, swamps, and rivers. So basically, the sources of fresh water is your surface water, frozen water, groundwater, and rainwater. And again, in surface water, you can get it from lakes, ponds, streams, rivers, reservoirs. And again, groundwater, we can get it from open wells, tube wells. Surface water, that is water on the surface of the earth, that is like a river, lake, wetland, even seas and ocean. So that also we can call it as surface water, but that is not drinkable. So non-saline surface water, it is replenished by precipitation. No, only on that we trust, right? The rainwater, we trust in that. And it is lost through evaporation. So it's a cycle. So we get it from rainwater, again we lose it through evaporation, seepage into the ground. Again, from there it becomes groundwater. Plants are using it. You call that as transpiration, and mankind, we use it for agriculture. Okay, so it is a cycle. So water uh, usage, no, replenishment, and again usage is a cycle. Water cycle, a very important concept of what we have studied right from our school days. See how the surface water is getting evaporated, and then it is getting condensed, and how it forms clouds, and from there we get the rainfall, that is known as precipitation. Again it reaches the ground, ground water gets stored there, and through seepage it comes back to the surface. Okay, so this is a cycle, and it's a cycle of nature. No, it happens again and again and again. And basically this surface water, no, it is available in the form of lakes, ponds, streams, and river. And groundwater, what is groundwater? It is the water present beneath the earth's surface, and so soil pore spaces, and in the fractures of rock formation. So basically it is beneath the earth crust. And these are some examples: open wells, tube wells, artesian well, infiltration galleries. Okay, these are some examples. And frozen water. Frozen water is the water, example is the water that is stored in Arctic and Antarctic in the form of glaciers and polar ice caps. The water present in even in Himalayas, no, which is in the frozen form. So everything that comes under frozen. Oceans and seas. So this is the water that is stored in seas and ocean as surface water, but it cannot be used directly for any usage. Maybe through osmosis and any other process we can convert it into usable form or drinkable form. The next is rainwater, and this is where we trust, right? So if we have to have this water cycle continuously, we should be trusting this rainwater. This is a major source of water, and it flows into rivers and finds its way back into the sea. And again, just now we studied the cycle, how it goes on. Hmm? And the next one is, where is this water used? Everywhere and everywhere and everywhere, right? We use it everywhere and for everything. No, for irrigation purpose, for domestic usage, for industrial usage, for institutional usage, for public usage, for navigational purpose. Everywhere we have this water usage. Hardness of water, very important topic. That's the next segment of our discussion. When do we call a water as hard water? So if you remember, when we were discussing, we said that water is basically having no taste and no smell. But how do we get this taste? By presence of salts, right? Naturally, we have salts present in water. But if this salts, especially calcium and magnesium salts, if it is in excess, we call such water as hard water. And how will this calcium and magnesium be present? They will be present in the form of bicarbonate, sulfates, chloride, and that will create hardness in water. And how do we find out that the water is hard? No, generally soaps will create foam, but if the water is hard, we don't get that foam. That is, hard water will not lather, will not give lather. Okay, so such water we call it as hard water. And you see what is happening here. Hard water does not easily lather with soap, as a salt of calcium and magnesium, they react with soap to form insoluble organic salts. Now you understand, right? Why we are not, no, it is not dissolving. Instead, we are getting an insoluble organic. Based on hardness, we can classify water as soft water and hard water. If you see up to 50 ppm, ppm is parts per million, water is very soft, and more than 100 you call it as hard, and if it is more than 300 ppm the water is very hard. Okay, so the if we use it for industry or if you use it in domestic purpose, everywhere that water will be a problem because of its hardness. So why water is hard? As I already told you, the hardness could be classified as temporary and permanent hardness. And temporary hardness, if the water is consisting of bicarbonates of calcium and magnesium, you call it as temporary hardness. And permanent hardness, it is due to the presence of sulfates, nitrates, and chlorides of calcium and magnesium. Okay, I'll repeat. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium, and you call it as temporary because it can be removed by boiling. Just a very easy process, you can remove the hardness. Whereas permanent hardness, we cannot remove it easily. You need some special methods to remove the permanent hardness. So as we already discussed, temporary hardness is due to the presence of bicarbonates of calcium and magnesium. And why do we call it as temporary hardness? Because it can be removed easily by boiling. And what will happen when temporary hard water is boiled? The carbonates will decompose with liberation of carbon dioxide and precipitation of insoluble carbonates. Okay, so that one layer that is formed no, when you heat it is your carbonate salts. Okay, so so simple boiling and filtering of water, you can just remove the temporary hardness. It's always safe to boil our water. And then permanent hardness, it is due to the presence of calcium chloride, calcium sulfate, magnesium chloride, and magnesium sulfate. Like if you have this in water, you uh, call it as permanent hardness. And this type of hardness, they do not decompose on boiling. So permanent hardness can't be removed easily, but it can be removed by using lime water. So what will happen as you add lime water, you will have precipitate of your sodium sulfate, or your magnesium hydroxide. So like this you can remove the uh, your sulfate salts. And yeah, units. How do you express this hardness? You express in the form of parts per million or in degrees, either in degrees or as parts per million. What is parts per million? It is a very common unit to indicate concentration for small values. 1 part per million is 1 part of solute per 1 million parts solvent. And it can also be expressed as milligram per liter. So 1 ppm is also equivalent to 1 milligram per liter. In other words, you can also call it as American hardness. Okay. Similarly, in degrees, you can also express hardness in degrees. The number of grains of calcium carbonate which is present in 70,000 grains of water. So this is another way in which you can describe hardness. Yeah, so these are some other ways. You call it as grains per US gallon GPG, then GPG imperial. Okay. Yeah, so in the beginning itself, we talked about this disadvantages. Hard water is causing so much of problem. No, even in our houses, if you see in the bathrooms, in our sinks, no, if our water is hard, what will happen? Basically, you will have clogging, and you have one yellowish layer, no, that is getting deposited all over our sink. So that's a very common problem that we face, and that problem, will be in multifold when you talk about industry. So there are numerous disadvantages both in the case of domestic as well as industrial purpose. And we also said it's a very difficult for washing itself, no, because it does not lather, so you don't have proper cleaning. The cleaning process is not properly done if it is hard water. Yeah, so that also even your utensils. So when we are using hard water for boiling, or when we are cooking with hard water for a long time, even our utensils get damaged, right? So there is a deposit of the calcium and magnesium salts, no, that will definitely ruin our utensils. Hard water is a very serious problem, especially in our day-to-day usage, that is in domestic usage and in industrial usage, and also in steam generation. These are the areas there are so many challenges ahead, especially when we use hard water. So if you see in houses, so this we have faced it in our everyday life. What happens when we are using it for washing? Hard water, when used for washing, it does not lather, and also it gives that precipitates of calcium and magnesium. It causes wastage of lot of soap, and also some traces of salts. I told you, no, that is getting no, accumulated in your sink, and even in when you bathe also the same problem exists. And cooking, we talked about the utensils, now how a deposit or a layer is formed in our utensils, and more fuel is required, more time is required for cooking. No, certain foods do not cook soft in hard water. No, you don't, you cannot make your food soft while you cook in hard water. So that is also, even tea or coffee, you cannot get the exact taste if you cook using hard water. And drinking, definitely it will not give a good taste, and even that is not safe for our health, because at one point of time you might uh, face problems because of this calcium deposits, especially in our kidney, stones, formation of stones. So you have a lot of challenges because of the usage of hard water. Next is industrial and uh, boilers. Okay, so using hard water in boilers, it will result in coating of carbonates inside the tube, and that will affect the efficiency of the boilers. So hard water release excess oxygen, and that will change the pH of water. And again, it will react with the surface material. Finally, it will lead to gradual corrosion. Your whole boiler will start corroding. And if you see in industrial purposes, industrial usage, uh, there is a big challenge for textile industry, sugar industry, and even for concrete making, and definitely in pharmaceutical industry. So there are so much of challenges ahead, especially for while using hard water. What will happen? Hard water causes much of the soap to go as waste, and all those waste we have to throw it off into our nearest ground. So definitely it is going to be a big problem. And the fabrics that which we are using hard water, what will happen is they do not produce the exact shade of color that you require when we use hard water. And iron and manganese salts contain water, again, that will give a colored spot on fabrics. If you have iron and manganese salts, that is again a separate problem. We'll be seeing that also in the upcoming slides. Sugar industry. Water that contains sulfates, nitrates, alkali, and sugar refining. It causes difficulties in crystallization of sugar. Concrete making, water containing chlorides and sulfates. It is used for concrete making and it affects the hydration of cement. Pharmaceutical industry, definitely it's a huge challenge. It is used for preparing pharmaceutical products like drugs, injection and ointments, and we might result in some undesirable product because of the hard water that is used. So this is again a steam generation is also a big challenge because boilers are used in steam generation. If the hard water is fed directly to the boilers, it will give a lot of troubles, especially the sludge formation. That is what I told you, a layer would be formed. Sludge formation, corrosion, foaming, priming and foaming, caustic embrittlement. No, finally your product, whatever material that you are using, that itself will get damaged. Effect of iron and manganese in water. So far we have studied about the problems that we are facing when we have calcium and magnesium salts. But this one, it is going to be even more challenging because in certain places you have iron and manganese in excess, especially when you talk about deeper wells where the water is in contact with the rock for a longer time, and even in coal mining regions, so where you have this mining activities, there also you have excess amount of iron and manganese in water. So they and if you have iron, you will also have manganese, so that's a combination. Iron and manganese will exist together in groundwater, and manganese occurs in a lower concentration compared to iron. So iron and manganese, they are common elements in the earth crust, and as water percolates through soil and rock, it will dissolve these minerals and carry them into groundwater. And as I told you, when you have a deeper wells which is in contact with rock and mining activities, if there is any mining activities carried out, there also, so in that area also you have more of iron and manganese. So what will happen? What are the problems? We'll study. Iron and manganese. So we have a lot of problem caused because of the presence of iron and manganese, especially its taste. The taste of the water, the odor, the color, everything will change because of the presence of iron and manganese. Iron will cause a reddish brown stain. Especially when you wash it. Even in your utensils, it will have a reddish brown stain. Manganese causes brownish black stain on the same material. If you have excess of manganese, your cloth and your utensils will have a brownish black stain. And even if you use detergents also, the stain cannot be removed. So definitely it's a challenge, especially for washing our clothes. And water contaminated with iron and manganese, they often contain iron or manganese bacteria. So these bacteria feed on the minerals in the water. They do not cause health problem but do form a reddish brown or brownish black slime in toilet tanks. Again, that will cause clogging. We have other challenges because of this water that consists bacteria. And yeah, so if it is present in drinking water, what will happen? It will impart a strong metallic taste. You cannot drink it directly. So water coming from wells and springs with high iron and manganese uh, will be, initially if you will have colorless, but as days moves on, you will get an orange, brown or black stains. Okay, when it is exposed to oxygen. Iron and manganese deposits built up in pipelines, pressure tanks, water heaters, water softening equipment. So you have again a lot of challenges if it is going to be iron and manganese in your drinking or in your water for domestic purposes. And the basically you can divide the ions effects on skin, effects on health, effects on food and beverage, and effects even in your the utensils, that is your appliances. The last part of our discussion is going to be the estimation of hardness by complexometric titration. and the ligand that we are going to use is ethylene diamine tetraestic acid. So as we have all studied about EDTA, you all know that it is a ligand, or it's a chelating ligand which goes and clings on with the metal, forms a complex, and that complex is estimated here. Okay, so it is based on complexometric titration, where hardness of water is determined by titrating with a standard solution of ethylene diamine tetraestic acid, and again which is a complexing. As such, we can't take EDTA because EDTA is insoluble in water. We are taking sodium salt of EDTA. Okay, we are taking a salt of EDTA, and this EDTA will form either 6 coordinated or 4 coordinated complex with a metal ion. So we'll be finding out the total hardness, temporary hardness, and permanent hardness. So what contributes for total hardness? Total hardness is contributed by all the salts, that is calcium bicarbonate, calcium chloride, calcium sulfate, all the salts together, it contributes for total hardness. So total hardness of water is estimated by titrating the sample water. So you can collect the sample water either from your house or from any nearby area where you want to find out how much is the hardness is. So you can take such water as your sample water, and you can titrate it against EDTA, and you can use EBT as your indicator. So the EBT itself will form a complex with calcium and magnesium, but it forms a weak complex. So as you add EDTA from your burette, what will happen? Your EBT will be cleaved off, and that EBT at one point of time, all your EBT will be cleaved off, and it will be free EBT. That final solution will be the color of your free indicator, that is steel blue. Okay, so you'll get a steel blue color at the end of your titration, and the whole experiment happens in the presence of buffer solution. Okay, so you carry out the experiment in the presence of buffer. So this is a very simple experiment, but from which you can calculate. Yeah, once you find out total hardness, what we'll do is we will boil off the temporary hardness, that is the salts that contribute for temporary hardness can be removed by boiling off. Then no, you can remove it using a filter paper, the one which is no, forming a layer. Your calcium bicarbonate forms a layer, and that can be removed by using a filter paper, and that the remaining will contribute for permanent hardness. Again, the same titration can be carried out to find out the permanent hardness. Okay, and this is the reaction no that is behind your experiment. How your calcium and magnesium salts that is responsible for your hardness reacts first with your EBT in the presence of buffer solution. Initially it gives a wine red color, and then as you start adding EDTA and all your EBT is cleaved off, you will get the color of the free indicator, that is steel blue or blue in color. And this is your colorless, your stable complex, or your calcium EDTA or magnesium EDTA complex that is formed, right? So this is your the reaction behind your experiment. Yeah, so this is the color, that wine red that I'm talking about, as you add your indicator, and as it cleaves off, you get your steel blue color. Hmm? Okay, very simple and very interesting experiment. You can try out and you can find out the hardness in your own house or in your own area where you are living. Yeah, see, I think you can see the color, how it is before and after the titration, that steel blue and that wine red color. And you also have the calculations to find out temporary and total hardness and your permanent hardness. Okay, so very interesting experiment. You can try it out. Yeah, I have also given the procedure. You can refer to the procedure, and also the calculation part is also there. Yeah. Yeah, so I think we have studied a lot. We have gathered a lot of information, and I believe this topic was interesting for you, to learn about water, something which is a very, very essential part of us. So, meet you in the next discussion. So, thank you all. Cherish chemistry. It's have a wonderful day with water. Thank you.